Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of graphing functions and identifying features. This is standard A.3C in the great state of Texas, and we are using item number 27 off the 2018 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a blank coordinate grid here if we need it. A blank airplane was a paper airplane was thrown from the top of a building. The height of the paper airplane above the ground can be found using, here's our function. I'll write it a little bit bigger for us. Y equals, so we've got a negative slope, 1.5x plus 60, where x is the time that seconds that the airplane is in the air. How many seconds did it take for the airplane to land on the ground? All right, so x is our seconds. Okay, so we're looking for how many seconds did it take for the airplane to reach the ground. All right, so we need to interpret this a little bit here. We don't really necessarily need to graph it, though we could if we really wanted to. So this is already given to us in slope-intercept form. So we got y equals mx plus b. Remember, this b right here is our y-intercept. That's why it's called the slope-intercept form. All right, so it's plus 60. So it's very, very tiny, but it's right there. All right, so x is going to be my seconds, right? And then y, it says the height of the airplane above the ground can be found by using the function y equals. Okay, so all of this gets you y, and y goes back to the height. All right, so my y-axis is going to be my height. All right, so that makes sense. So it starts at 60. I guess we'll say 60 meters. 60 feet is not that tall of a building, so we can maybe say it doesn't matter, 60 something. And then it's got a negative slope, right? So there's my m, it's my slope. It's going to kind of come down at some point. It's going to keep falling, and I'm not sure if this is the correct slope. Then at some point it's going to hit the ground, all right? And then it can't go negative. This is a real world situation, so it can't be negative unless there's a hole maybe it can go into in the parking lot or something. And so we're looking for how many seconds did it take to reach the ground. So the seconds is x. So x equals, that's what I'm looking for, when y equals, here's my height. What happens when you're hitting the ground? Well, when you're hitting the ground, y is 0. So I want to know where on this x-axis I'm going to find that this height here is going to reach 0. That's the x-axis. How many seconds is that? So really what I'm looking for, all of this is making me look for the x-intercept. And actually, when we're looking at the x-intercept, we are looking at a coordinate pair. But sometimes we will just call the x value of the x-intercept the 0, because that's what happens when y equals 0. Okay, so we can do that. We could just substitute 0 in for that right there. 0 equals negative 1.5x plus 60. All right, now let's solve for x, because I want to know what x equals, how many seconds it takes when y is 0. All right, so I'm going to get negative 60 equals negative 1.5x. Divide both sides by negative 1.5 to isolate that 0. And you're going to get a positive 40. All right, so right around, I think it's right there on our graph actually. At 40 seconds, that airplane is going to hit the ground. So now all we need to do is graph it. In Algebra 1, you get what we call a floating decimal. So really you can put it anywhere. Might as well put it all the way over and to the right, 4, 0. Just make sure you're bubbling that in correctly. You don't need to bubble in the positive over on the left. It's assumed to be positive. That's your answer.